Our video tutorial this time is about proving trigonometric identities. In proving trigonometric identities, we are going to use the basic trigonometric identities like the quotient identities. Tangent x is equal to sine x over cosine x. Cotangent is cosine over sine. Reciprocal identities. Cosecant x is equal to 1 over sine x. Secant is 1 over cosine. Cotangent is 1 over tangent. Pythagorean identities. This is derived from the right triangle. Sine squared x plus cosine squared x is equal to 1. 1 plus tangent squared x is equal to secant squared x. And the third Pythagorean identities. Another one, sum and difference identities. We have here the sine of the sum of two angles x and y is equal to sine x times cosine y plus cosine x times sine y. So these are the sine of the sum of x and y and sine of difference of x and y. The cosine of the sum and the cosine of the difference. The tangent of the sum of x and y and the tangent of the difference of x and y. These are the basic trigonometric identities. We have also the double measure identities or double angle identities. The sine of 2x is equal to 2 times sine x times cosine x. The cosine of 2x, there are three values. There are three forms of cosine of 2x. Cosine squared x minus sine squared x, or it is 2 times cosine squared x minus 1, or 1 minus 2 times sine squared x. The tangent of 2x is equal to 2 times tangent x all over 1 minus tangent squared x. Half measure identities, we have sine of x over 2. This is the equivalent plus minus square root of 1 minus cosine x over 2. The cosine of x over 2, this is the identity, and so with the tangent of x over 2. For the tangent of x over 2, there are three forms. Now, the second one is sine x over 1 plus cosine x, or it is also equal to 1 minus cosine x over sine x. Next, the product to sum identities. We have here the product of sine of x times cosine of y. It becomes the sum of the sine of the sum of the two angles x and y plus sine of the difference of the two angles x and y. So these are the product of sine x and cosine y. Cosine x times sine y. The product of cosine x and cosine y. The product of sine x and sine y. These are the basic trigonometric identities. We have also the sum two product identities. Okay, we have here the sum of sine x plus sine y. It becomes the product of 2 times sine of x plus y over 2 times the cosine of x minus y over 2. So we have here the sum, the difference, sum and difference of cosine and sine. Okay. Next, let's have an example. Prove that sine theta over 1 minus cosine theta is equal to 1 plus cosine theta over sine theta. We may work out on one side of the equation. From the left, sine theta over 1 minus cosine theta. We can multiply both numerator and denominator by the same value so that it is equal to 1. So multiplying both numerator and denominators. So sine times 1 plus cosine theta. The denominator, we are multiplying the sum and difference of two binomials. So we have here 1 minus cosine squared theta. From the Pythagorean identities, we may solve for sine squared x. So this becomes negative cosine squared x when we transfer from left to right. So this has the same form. So we can substitute 1 minus cosine squared theta by sine squared theta. Okay? Cancelling out common factor on both numerator and denominator. So we are left with 1 plus cosine theta over sine theta, which is the same as our right side. Okay, next example. Prove that 1 plus cosine x over 1 minus cosine x is equal to secant x plus 1 over secant x minus 1. We can work out the right side, transforming the secant x into cosine x from this reciprocal identity. Secant x is equal to 1 over cosine x. So substitute secant x with 1 over cosine x and rename the numerator and denominator into a single fraction. Dividing becomes multiplying with the divisor inverted. Okay, we invert the denominator, cancel out cosine, then it is equal to 1 plus cosine x over 1 minus cosine x, which is equal to the left side of the identity. Next example. Okay, prove that 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equal to 2 times secant squared theta. Okay, we will combine these two fractions into 1 with the LCD 1 plus sine theta times 1 minus sine theta. Okay, this is the LCD. So this LCD divided by 1 plus sine theta is equal to 1 minus sine theta, plus the LCD divided by 1 minus sine theta is equal to 1 plus sine theta. Okay, take note that opposite signs on the numerator is cancelled. 1 plus 1 equals 2. Multiplying these two binomials is equal to 1 minus sine squared theta. From the Pythagorean identities, if we are going to solve for cosine squared x, this becomes 1 minus sine squared x. So 1 minus sine squared theta is replaced with cosine squared theta. Or this can be written as 2 times 1 over cosine squared theta. From the reciprocal identities, secant x is equal to 1 over cosine x. We are going to square both sides of the equation. This is secant squared x equals 1 over cosine squared x. We can replace this one with secant squared x. Okay, then we know that it is equal to the right side of the identity. Next, prove that quantity tangent theta plus cotangent theta squared is equal to secant squared theta plus cosecant squared theta. We may work out on the left side, squaring the binomial. So tangent squared theta plus 2 times tangent theta times cotangent theta plus the square of the secant term, cotangent squared theta. From the quotient identities, tangent x equals sine over cosine, cotangent is cosine over sine. So we may substitute tangent theta and cotangent theta with sine theta over cosine theta, cancelling out. So what is left is only 2. Another one from the Pythagorean identities. If we are going to solve for tangent squared x and cotangent squared x, we have here secant squared x minus 1 and cosecant squared x minus 1. Substituting tangent squared theta with this right side of the identity And so with the cotangent squared theta, okay, and negative 1 plus 2 and negative 1 cancels out. So we are left with secant squared theta plus cosecant squared theta, which is equal to the right side. Next, prove that tangent x is over secant x minus 1 is equal to secant x plus 1 over tangent x. We are going to prove that the left is equal to the right. We can work out on the left side. We can multiply both numerator and denominator with the same, with a value, a fraction equal to 1. That is tangent x over tangent x. So multiplying numerators and denominators. Then tangent squared x from the Pythagorean identities. If we express tangent squared x, this is equal to secant squared x minus 1. Transferring 1 to the left, to the right becomes negative. And substitute tangent squared x with secant squared x minus 1. Okay. Then factor out the numerator. This is the difference of two squares. The factor of secant squared minus 1. Cancel out. Then we are left with secant x plus 1 over tangent x, which is equal to the right side. Next, prove that sine of x plus y plus sine of x minus y all over cosine of x plus y plus cosine of x minus y is equal to tangent x. Okay, so we are working with the left side of the identity. From our basic identities, the product to sum, the product of sine x and cosine y is equal to this right side of the identity. If we are going to cross multiply the two to the left, so we are left with sine of x plus y plus sine of x minus y. So we can substitute this numerator and denominator with this one. Okay, the numerator is 1 and this is for the denominator. Cancelling out cosine y and 2. So we are left with sine x over cosine x, which is equal to tangent x, which is equal to the right side. Okay, next. Prove that cosine 2 theta equals 1 minus tangent squared theta all over 1 plus tangent squared theta. We will work out the right side of the equation. From the Pythagorean identities, we can solve for tangent squared x. Transferring 1 to the right becomes negative. And substitute tangent squared theta with secant squared theta minus 1. Okay. Then distribute the negative sign and so with the positive sign at the denominator. Negative, 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 and negative is positive. Then 1 and positive 1 and negative 1 is cancelled. Okay, 1 and 1 is 2. Distribute the denominator to its term in the numerator. So this becomes 1. Then from the, or we can rewrite this one as 2 times 1 over secant squared theta. From the reciprocal identities, secant x is equal to 1 over cosine x. If we are going to square both sides of the equation, or if we get the reciprocal on both sides, reciprocal of 1 over secant x and reciprocal of 1 over cosine x is equal to cosine x. And squaring both sides, then 1 over secant squared theta has the same form as cosine squared theta. Substitute here. Okay. Cosine squared theta. This one cosine squared theta from the basic reciprocal identities. Next, from double measure identities. Cosine 2x equals to cosine squared x minus 1. We can replace this expression with cosine 2. Okay, this one. Referring to the identity. The same expression. 2 times cosine squared times the variable of the angle minus 1 is equal to cosine of this is equal to cosine 2 theta, which is equal to the left side. Okay. Next, prove that cotangent of x over 2 is equal to cosecant x plus cotangent x. Okay, we can work out at the right side of the identity, making use of the reciprocal identity. Cosecant x is 1 over sine x. Cotangent is the same as cosine x over sine x. Okay. Renaming into a single fraction, the LCD is sine x. The numerator is 1 plus cosine x. We have here the half measure identity. Tangent of x over 2 is equal to sine x over 1 plus cosine x. If we are going to get the reciprocal of this fraction, 1 over, then get the inverse. The sine x becomes the numerator. So that if we simplify this fraction, this 1 divided by sine x over 1 plus cosine x, divide becomes multiply, but get the inverse of the divisor. So this becomes the denominator and this is the numerator. If we multiply, we get the same fraction. In other words, this fraction is the same as this one. We may work out on this complex fraction with sine x over 1 plus cosine x has this value, tangent of x over 2. So we can substitute this one with tangent of x over 2. Then, from reciprocal identities, 1 over tangent x over 2 is the same as cotangent x over 2, which is the same as the left side of the equation. Next, prove that sine 2x minus sine 2y divided by sine 2x plus sine 2y is equal to tangent of the difference over the tangent of the sum of x and y. We can work out with the left side, making use of the Sum Two Product Identities. We have here the sum of the sine of x and y, sine x minus sine y, and sine x plus sine y. Our x here corresponds to 2x. Our y corresponds to 2y. So, using this basic identities, we have here 2, this one 2, cosine of 2x plus 2y. So that cosine of x plus y. Okay, following the identity, cancelling out 2, common factor, and we can factor out 2 in the numerator in each of the term, then cancel out 2. So we are left with the simplified form, cosine of x plus y times sine of x minus y over sine of x plus y times cosine of x minus y. We can separate the fraction cosine over sine of the sum times the sine over cosine of the difference. From the basic identities, cosine over sine is equal to cotangent of x plus y, and sine over cosine is tangent of x minus y. Cotangent is the reciprocal of tangent from our reciprocal identities. So we can transform this one with 1 over tangent of x plus y times tangent of x minus y. Combining the two, we have tangent of x minus y over tangent of x plus y, which is the same as the right side of the equation. Okay?